Hey, I'm Scott. I'm presenting to you on the Model Context Protocol. I'll start with a brief bit of context, followed by a demo of a simple server with Claude Desktop. MCP was created by Anthropic, the company behind Claude. If you ask Claude who created the protocol, like I did, it also tells you Anthropic developed it to standardize how AI applications connect to different data sources and tools. The tool we'll be using MCP to connect with in these demos is an API provided by the National Weather Service. Let's start by running the server locally. Just click in here, run this command. We'll also run tail on the log file. See here it started and connected successfully. Gives a bunch of messages from the client and probably some messages from prior runs. Now let's make sure that Claude Desktop is actually aware of our server. Press this button and we see US Weather, the server that I've set up, and we see the tools made available by that server, get alerts, and get forecast. Let's see what happens when I ask Claude for the weather forecast for Wilmington, Delaware. See, it decided to use our get forecast tool here. And there's the forecast. Looking at the steps Claude takes, gets the coordinates for Wilmington, calls the get forecast tool with the lat long that it got for the city, and it gets back the weather forecast. And Claude Desktop cleans it up. Here in the tail log, we see a bunch more details in terms of how the forecast actually looks in terms of raw output. Now let's get into some of the code and configuration that makes this work. Starting with line 56, you see this decorator that defines this function as a tool. Go further down to line 66. This call against the API gets the endpoint, and if that call succeeds, then it makes another call in order to get the actual weather forecast. And the reason that the forecast itself just had these 5 elements here is that the way that this is hard-coded is only showing the next 5 periods. So if there were more, we would need to have changed this or made this configurable and passed it a different value in order to get more. Now to the question of how the desktop is able to see the tools that I'm running, we have to look to the configuration file. You see from the path it's sitting in application support, and I've told it here what command it's running and what arguments are being passed to it. And you see that that's where the application is running. So that's the code and that's the configuration for that particular server for the forecast tool. Let's try the other tool that the server makes available, the get alerts. So type in a different prompt here. Get the weather alerts for and see what happens. All right. So note here that it figures out that I misspelled the town that I put in, so it went on the assumption that I wanted the correctly named town, decides to get alerts, open this up, see that the request only requires the state. So it took what I put in the prompt and just pulled what it actually needed. You can see the response here. It's quite a bit longer. It shows a little thought process there. But here's what it shows, a more cleaned up, prettied up summary of the weather alerts. Little icons here. It lays out the warnings. It does use the actual town that I put in terms of situating it within a particular geography. So now that we've seen that, let's take a look back at the code. We see here that same decorator defines get underscore alerts as a tool. Go to line 45, we see the API call. It is a much simpler call, as you can see here. Just one call to make, no grabbing a geographic area necessary to make that call. And based on the data that comes back, it builds out the alert information that you saw. And that's it for this basic custom weather server.